Hi everyone. This video will show you the actual experimental steps for the reaction stoichiometry and the formation of a metal ion complex lab. Most of the data will be provided by your instructor separately. The video walks you through the steps needed to obtain those data. The data you're given should be recorded in the lab report for this experiment. We are using two different solutions here to make our complex ion product. A solution containing iron ion and the phenanthroline molecule. Both of these solutions are at 2.5 times 10 to the minus 4 molar. The first step we do is mix different ratios of the two solutions as shown in the table in your lab procedure. To do this, we place each solution inside a burette and then release the correct volume needed for each solution into a test tube. We first start with the iron solution, followed by the phenanthroline solution. You can see the reddish solution, which is a sign that the complex ion between iron and phenanthroline is formed. Although not shown in this video, we repeat this process until all the solutions are made. Next, we search for the best wavelength to make our absorption measurement. This wavelength is labeled lambda max, which stands for the wavelength of maximum absorption. To do this, we place 5 milliliter of the phenanthroline solution in a cuvette. This solution serves as a blank to set our spectrophotometer to the 0 level. Next, we take solution number 5 that we've made, which contains equal volumes of the two solutions, and pour that into another cuvette. To find lambda max, we place the cuvette containing the blank solution in the spec that is already set at 460 nanometers. We then adjust the absorbance reading to 0.000 to make sure we start at the right background level. As discussed in the pre-lab video, this is the same as what you do when you tare a balance to make it go to 0 before using it to weigh an object. We then take out the blank and put in the cuvette containing solution number 5. The absorbance reading that we see is then recorded in your lab report on the row marked 460 nanometers. We then change the wavelength to 470 nanometers on the spec and then repeat the blanking and absorbance measurement again. This absorbance is then recorded on the 470 nanometer wavelength row. Once we repeat all of the measurements, we will find a wavelength that gives us the highest absorbance. In this case, we find this following combination to be our lambda max. Next, we will use the lambda max to measure the absorbance of all our samples from 1 to 11. To do that, we transfer solution number 1 to a clean cuvette. We then blank the spec using the phenanthroline solution again. We take the blank out and put the cuvette containing solution number 1 in. The absorbance is recorded on our first mixture row. We repeat these steps until all the absorbance values are recorded. Keep in mind that your instructor will provide the rest of the data values for you.